Okay, so we'll discuss about electrostatic potential. Electrostatic potential is the scalar form of electric field intensity. Electrostatic potential we can find out by considering the formula, mathematical formula we can consider like work done to bring a positive unit charge from infinity to a point. So let's consider one charge Q is located here and another charge Q naught. We are bringing that charge Q naught from infinity to this point B. Let's consider this distance is R. So due to this Q, we have to find out the potential at this point B. Okay. So while we are finding potential, always we have to consider two different points. We cannot find out the absolute potential of any point. We can find out only the difference between potential of 2 points. And because of that, to find the potential, the reference point we are considering as infinity. And we are considering at infinity, potential due to this charge Q is always 0. Now, due to this charge Q, what should be the potential at this point? Now, to find the expression for potential mathematically, there are two different approaches. One is, we can consider work done due to external force. What is that external force? This Q naught charge while we are bringing from infinity at this point, one force must be acting along this direction. So, that force is bringing this charge Q naught from infinity to inside of the electric field due to this charge Q. That force will be external force. And if we are considering work done due to external force, in that case potential V will be equal to directly work done due to external force by this charge Q naught. That will be electrostatic potential. Now in the other way also we can consider this charge Q is applying Coulomb force on this charge Q naught. What should be the direction of that force? In this direction. And this Coulomb force also we can consider as conservative force. Then in that case, if we are finding the potential V, then we can write electrostatic potential V equals to negative of work done due to conservative force by charge Q naught. So this is the difference. Now most of the time we will use this concept only because some limitations are there. Like here, if we are considering this external work, external force, in that case, we have to consider the system, this charge Q naught must be in equilibrium, means there should not be any acceleration on this Q naught charge due to the external force. So that is the limitation. And while we are considering this conservative force, that time we are not considering that type of thing. So most of the time we use this formula. And here one more we can do one consideration, that potential V equals to, also we can write minus of integration E dot dr. So this is one relation between electric field and potential. So in the opposite way also we can write E equals to, so if we are writing in scalar form also we can write in this way, E equals to minus of dV by dr. This formula is valid only if angle between E and dr is 0 degree. So that is one limitation, but one general expression we can write in this way. Now if we are using this formula, in that case this conservative force F equals to, we can write K Q Q naught by R square for this point B. And if we are applying this expression for conservative force, in that case potential V equals to, after calculation we will get K Q by R. If we are putting the value of K, in that case we get 1 by 4 pi epsilon naught Q by R as the expression for potential. And unit of potential is volt.